its own molecule has 12 valence electrons. Okay, the -2 charge means that we will add 2 electrons to give us a total of 14 bonded electrons. The first thing we're going to do in this diagram is we are going to draw the valence electrons for the 2 O atoms. Each will have 6 valence electrons. 1, 2, 3, 4, 5, 6. On the other side, 1, 2, 3, 4, 5, 6. Now that we have our valence electrons drawn in, we will start filling in the molecular orbitals. First, we will start with the sigma 2s orbital, where we will add 1 electron from each O atom in the 2s level. 1, 2. And then we move on to our anti-bonding orbital, which would be sigma star 2s, where we will add the other 2 electrons. 1, 2. By doing this, you are able to see how all 4 electrons are bonded in the molecular orbitals. Also, do not forget to draw in your dotted lines, connecting your molecular orbitals to your atomic orbitals. Next, we're going to move on to the 2p level. We will start by taking 1 electron from each O on the 2p level and adding it to the sigma 2pz level. 1, 2. Next, we will add to our pi levels, which would be pi 2p x and pi 2p y. We will then fill up those orbitals. So there would go an electron in the pi 2px and then the pi 2py. And then we go back and add 1 electron to both of those, which gives us 2, 4, 6, 8, 10 electrons so far. Now we will add 4 more electrons to the next 2 levels. Pi star 2px, pi star 2py. We will then add electrons 11 through 14. So 1, 2, 3, 4. That gives us our 14 electrons. Notice that the sigma star 2pz orbital remains empty. Once you're done filling in your orbitals, do not forget the dotted lines connecting the atomic orbitals to the molecular orbitals. Okay, now that we've drawn in our lines, filled in our orbitals, and labeled everything for the diagram, we will go on to our next section. Our electron configuration will be sigma 2s 2, because there are 2 electrons, Then it will go sigma star 2s2 sigma 2pz2 sigma, oh nope, not sigma, sorry. It will go pi 2px2 pi 2py2. Then our anti-bonding orbitals, which will be pi star 2px2 and pi star 2py2. And then that gives us our electron configuration. Next, we will do our bond order. So first we'll take 1/2 of 2, 4, 6, 8 electrons minus 2, 4, 6 anti-bonding electrons. 8 minus 6 is 2. 1/2 of 2 is 1. This gives us a bond order of 1. The number of unpaired electrons would be 0. And O2 2- magnetic properties would be diamagnetic. The bond length would be the same as F2, and the bond dissociation energy would also be the same as F2.